deleting from the end of an array. Deletion of the end of the array is similar to people standing in a line. As long as a queue, the people most recently joined a queue at the end can leave at any time without disturbing the rest of the queue. So deleting from the end of an array is the least time-consuming of the three cases. Let's recall the insertion at the end of the array was also least time-consuming case for the insertion. So let's create a array, integer array, array, and new inter 10 element. So this we need to create a room for 10 element, right? For this array, so we need to declare a integer array with 10 element, and the every element contained is now is a default is a currently is a 0. So we need to set a length variable is initialized to 0. They can track the current how many elements add, and then we can set the for loop to add some element. I is start from 0 and I less than 6 and I plus plus, and so we need to put some elements into it. We put the first 6th index of the element into the array. Inter array, the length is get a value from I. So I is 0, 1, 2, 3, 4, 5, and the length is also need to increment. Notice the length variable. Essentially, this variable keeps track of the next index that is free for inserting a new element. This is always the same value as the overall length of the array. When we declare an array of a certain size, we just simply fix the max number of the element it could contain. Initially, the array doesn't contain anything. Thus, when we add new element, we can increment the length variable accordingly. When we deletion the end of the array, is simply as reducing the length of the array by 1, decrement by 1, and when we insert it, it's like a increment by 1. So after that, we can print out the for loop to print out the result. Int I start from 0 and I less than inter array dot length, and I increment by 1, and we can print out system dot out dot print line index plus I plus contains plus inter array at I. Then we can print them out. But notice what's wrong here. You just remember the definition of the length and capacity. When we use the int.length, the built-in function length, we just looking for the every validated index of the array. So it is the capacity. So, but in fact, we only want to look at the one that we just put into the element to put the value to the array. So let's fit it quickly. We just iterate this for loop with length variable. We just create instead, right? So just delete them and run them. Yeah, it worked. So this is we only print out what we create inside it. And if we want it later, we just before them, we just decrement the length. Minus. Yeah, we already deleted the index 5 content 5 at the end. Yep, that is. Even though we call it a deletion, it's not actually freed up space for a new element, right? This is because we don't actually need to free it up for any space. We're just simply overwriting the value of the certain index to delete the element of that index. Seeing as the length variable in our example tells us what is the next index where we can insert a new element. So this can reduce it by 1 to ensure that next element is right over the deleted one. This was also indicate that the array now contains one list element, which is exactly we want to programmatically. Let's talk about deleting from the start of an array. Deleting the first element is the causiest of all the deletion operation for an array. If we want to delete the first element of an array, it will create a vacant spot for the 0th index. To fill that spot, the empty space will create it. So it will shift the element at the index 1 and one step to the left, to the right, to the left. So going by the ripple effect, every element all the way to the last one, this will be shifted one place to the left. Hence, empty space is created at the end of the array. This shift of element takes of n time. Well, n is the number of elements in the array. Create a for loop here. It start enter I start from 1 and I is less than length I plus plus, and we set a for loop. Remember, we have to shift each element one position to the left. One position to the left means every element inter array I minus 1 is the left neighborhood, gets the value from I, and then we need to reduce the length array, length of the array, length variable of array. Otherwise, we will lose the consistency of the aside. This means the array variable is the only thing that controls when the new element is be added or we need to delete. T is only the variable that controls everything. Right, so we need to keep track of this length. So decremented by 1 because we just deleted. So yeah, so now it become only 4. But if we didn't, it will come out. It will be print like this. So we just delete the index 0. So now it contains the 1. 1 is originally it is the index of the, it is a value from the index 1. We starting from the index 0, we move every element one position into its left. So this effectively deleting the element at index 0. We also need to reduce length by 1. So that the next new element will insert into the correct position. Let's talk about deleting from anywhere in the array. For deletion at a given index, after deleted item, the empty space will create it and it needs to be filled. So for the index we are deleting, each of the elements to the right of it will shift to the left by 1, and deleting the first element of an array is a special case of deletion of a given index. Well, the difference it is the special index is 0. So we want to delete an element in the index 1. We need to create a for I. Int I is start from what? Because we need to move over all the element after it. We pick the 2, right? Start from 2, and I is less than length, and I plus plus, and inside for loop is inter array at I minus 1 get the value from the inter array at I, and again we need to the length need to be consistent with the current state of the array. So length we just delete an element, so the length variable need to be decrement, and we can print out. So we did it. This in the middle 2 is be deleted. Before that it is index 1, right? This works exactly like deleting the first element, except we don't touch the element that are in the lower index than the element we are deleting. I mean, this element in the left side, we don't touch it, we don't move it, and we just shift the element in the right side, right? So this shift element at the right side, it take O of k time, where k is the number of the element that in the right side of the given index. Since potentially k is approximately equal to n, so we can say that the time complexity is the operation. This operation is also of n.